So we are on section 3.1, quadratic functions. Okay, and we talked a little bit about quadratics when we were dealing with factoring. Okay, but today we just look at quadratic functions. We look at their graphs. We talk about the important parts of them, like a vertex and axis of symmetry, that kind of thing. So we're going to start off with the general form of a quadratic function, and that's going to be f of x equals ax squared plus bx plus c. Now, if we're given the general form, we can find the vertex with the following formula. And I will label all this for you on a graph. We're just going to kind of write it down first and write down those formulas and steps so that you know, okay? And we can find the vertex in general form as negative b over 2a with f of negative b over 2a. And guys, all that means is if you find that x coordinate, take that x, plug it into that function and find the y that goes with it, okay? But that's going to be the vertex. We'll go ahead and define the vertex of a quadratic function, and it is the highest or lowest point on the parabola. Now, a parabola is the actual graph, the shape of the function that a quadratic makes, okay? So if let's see, I'm going to wait to draw it, okay? If I'm in general form, I can also find the axis of symmetry, okay? And the axis of symmetry is going to be x equals negative b over 2a. You'll notice it's the x part of the vertex, and that's because the axis of symmetry actually runs through the vertex. And an axis of symmetry is just if we were to cut that parabola in half or fold that parabola in half where it could lay on top of each other, that line that we folded over is the axis of symmetry. So it cuts the parabola in half. Okay, now I'm going to go ahead and draw you a picture. Okay, so let's say that I have let's say that I have a quadratic function and it has a vertex at 2, negative 1. Okay, so what we see here is that this point right here is my vertex. In this particular graph, its vertex is at, like I said, 2, negative 1. Okay, and that means its axis of symmetry is this dotted line right here. It's dotted vertical line. Okay, and we can draw a little arrow. That's my axis of symmetry. Okay, and this particular graph has an axis of symmetry at x equals 2. Notice that x equals 2 has the same x value as that x coordinate for your vertex, okay? Your axis of symmetry runs through your vertex. Now, we have all the same points and parts. Sometimes they don't put it in general form. Sometimes they put it in actual vertex form. That's when vertex form is the same as standard form. That's when they're being nice to us, okay? So we can say standard form. You'll hear some textbooks call it vertex form because, yeah, that's actually what it shows us is the vertex. And standard form is A. Let me scoot that down for you guys. It's probably going to take the tip off of, nope, it didn't. Okay, A times x minus h squared plus k. Okay, and it will be, I should actually put f of x there. That looks like a negative. I'm sorry. F of x equals a times x minus h squared plus k. Our vertex here, let's see how I stack that. Okay, so our vertex here is actually really easy, really nice. And it is going to be HK. Okay, and of course my axis of symmetry. We've talked about that it is the x part of your vertex, so it's going to be x equals h. Okay, so those four things are very important. This part right here, when it's in standard form and you're doing HK, that's pretty easy to pick out the vertex there. You do need to change the sign of h. Notice there's a negative. It's x minus h squared. So like on the circles that we did when we had HK, notice we had HK there too. But you had to change the sign of both because it was x minus h squared plus y minus k squared. This one's a plus k. K's fine. You don't have to change the sign on the K, but you got to change the sign on the H, okay? These are a little harder to remember. But like I said, if you can just remember that negative b over 2a, you'll see what f of negative b over 2a is. That's just the corresponding y to that x value. So really all you have to remember is negative b over 2a. Okay, and that is the x part. You can find the vertex if it's in general form. Okay, let's give a list of how to graph quadratic equations, because we're going to do that. Okay. Number one, we are going to determine if the parabola opens upward or downward. Okay, now that one's pretty easy. We're going to look at the a value, which is the number that's in front of x squared. If I'm looking at either form, if I'm looking at general form here, here's my a. If I'm looking at my standard form, here's my a. Okay, that's what they're talking about when they say look at the a. When we say look at a, look at a. I'm going to make him blue. Okay. If a is positive, so greater than 0, it will open upward. Okay. If a is negative, it will open downward. Okay. Pretty simple. You look at it and you go, okay, well, I know that graph's going to open upward or it's going to open downward. And guys, when we're graphing quadratic functions, they're all going to look like this. They're your U's. They're going to open up, or they're going to open down, or they're going to be over to the left, they're going to be to the right, they're going to be lower, they're going to be in one of the quadrants. But they're always going to look like that. They might be a little skinnier, they might be a little wider, but they're going to have that same U shape, okay? So, number 2, we want to find the vertex. Okay, so that means we're either going to say negative b over 2a, depending on the form, with f of negative b over 2a. Or, if it's nice, we just look for hk. Okay? Well, so we're going to graph that. Then we're going to find x-intercepts. How do we find x-intercepts? Yes, set y equal to 0. Solve for x. Okay. Then, step 4, well, if we find x-intercepts, we're going to find y-intercepts. Find y-intercepts. We're going to, this time, set x equal to 0. Solve for y. And then finally, 5, we want to plot the x-intercepts, y-intercepts, vertex, and any additional points. Okay, if needed. You really only need 3 points, but sometimes it's not the 3 points that we want, so we have to pick some more. Okay, so we have looked at both forms. We've talked about both forms, how to find the vertex and the axis of symmetry. You guys already know how to find the x-intercepts and the y-intercepts, and then we can determine if it opens up or down based on if A is positive or negative, okay? Then we talked about how we go about graphing it without a calculator. I know most of you are accustomed to, graph this function. You pick up your handy-dandy TI-84 Plus CE graphing calculator. You hit the y equals button. You just make sure that that function's in y equals, solve for y. You type it in, you hit graph, you do a zoom. You zoom in, zoom out so you can see it, or you do a zoom box. And there you go. There's your nice picture. Then you can do a trace and you can find exact points. Okay, I know that's how that usually goes. Or you just type it in Desmos and then you just touch where the points are. That's even nicer on Desmos. How many of you used Desmos last year? Did you, Alex? In Algebra 1? No, did you use 84 or an Inspire? 84? What about you two, when you were in high school? I'm assuming it was within the last 5 years. 84, okay. Tony, what about you? How long has it been since you've been in high school?
No, last year.
Last year? You remember what you used? Like in Algebra 1? Algebra 2?
Really, but she said something familiar.
The 84?
Yeah.
The TA-84? Yeah. Josh, you may not have used... You had that, yeah. That's because it's been a little while.
Yeah.
And Edom probably no calculator. No. In math, like, did you get to use a calculator? No. Yeah, I didn't figure she got to. Okay, so we're going to graph without that calculator. I know, scary, right? It's not that. And you guys are more predispositioned to be able to see. Once I tell you the rules and you know what to look for, you can go, oh, here's this equation. I know it's going to look similar to this. You know what you should kind of get, okay? So let's look at example 1. We want to graph the quadratic function f of x equals negative 2 times x minus 3 squared plus 8. Okay, so we're going to follow our steps, right? The first thing that I'm going to look at, though, before I get into my steps, is this written in general form or is it written in standard form? Vertex form. Yeah, standard / vertex form. So this really matches with f of x equals a x minus h squared plus k. And once again, we write it because you guys have to know it, okay? You got it, there's no chart. You got to know it. You got to know the formula, okay? So that means I'm going to be able to easily pick out a vertex, okay? I'm going to be able to easily determine if it opens up or down, right? So in this particular case, what is A? What does A equal? A equals negative 2, so that means step 1, where I'm determining if it opens up or down, is it going to open up or is it going to open down? Down, okay? So that means it's going to be very similar to something like this, where it opens down, okay? So we got that going for us. All right, step 2, I think it tells me I need a vertex, right? Okay, well, this one's friendly. I know that my vertex here is HK because I'm in standard form. So that means, now, I told you we got to change the sign of that H. So in our formula, it says negative 3, but that's going to be a positive 3. And then 8 stays the same. So I've got a vertex of 3, 8. Now I'm going to find some x-intercepts. Okay, so I'm going to go over here. I'm going to have to do a little math with my x-intercepts. Now, it says when we do x-intercepts that we need to set y equal to 0. Well, right now I have f of x equals negative 2, x minus 3 squared plus 8. Who's y? F of x. So I've got y equals negative 2, x minus 3 squared plus 8. We're going to change that y to 0. So 0 equals negative 2 times x minus 3 squared plus 8. Okay, well, that means I've got to somehow solve for x, right? This is why we did the whole factoring by square root property, that type of thing. Okay, so I'm going to subtract 8 from both sides. I know I need to get x by itself. Negative 8 equals negative 2, x minus 3 squared. I'm going to divide that negative 2 by both sides. That's going to give me 4 equals x minus 3 squared. So it was friendly. It turned back into a positive, so I'm not going to have an I there. So I actually do have x-intercepts. Now I know to get rid of that square root, to get rid of that square, I need to take the square root of both sides, right? So it's going to give me plus or minus the square root of 4 equals plus or minus the square root of x minus 3 squared. Okay. Square root of 4 is going to give me plus or minus 2. Okay, equals x minus 3. Why did I write the plus minus 2 there? I'm sorry, my bad, guys. Okay, we need to split that now because what do we really have? We have 2 equals x minus 3, and we have negative 2 equals x minus 3. Right? That's what it's telling me. It's what it's saying. I'm going to add 3 to both sides, and that's going to give me 5 equals x. I'm going to add 3 to both sides, and that's going to give me 1 equals x. Okay, so you found your x-intercepts. X-ints are at x equals 5, x equals 1. Okay? Now it says we need to find our y-intercepts. I think that was step 4. Was that step 4, y-intercepts? Okay. So I'm going to go over here. I'm going to do the same thing, except this time, on my y-intercepts, I'm going to rewrite it as y equals negative 2x minus 3 squared plus 8, since you guys have already told me that's what that becomes. And this time, to find my y-intercepts, I'm going to make x equals 0. So I have y equals negative 2 times 0 minus 3 squared plus 8. Okay, that's going to give me y equals negative 2 times negative 3 squared plus 8. That's y equals negative 2 times 9 plus 8. So y will equal negative 18 plus 8. Y gives me negative 10. So I have one y-intercept. Guys, that makes sense that we have one y-intercept and two x-intercepts because this is a quadratic. It has a degree 2. It's going to have two solutions. Okay? They may not be real solutions. You might have gotten an I in there, or may get an I sometime, but you're going to have two solutions. Okay? So my y-intercept is negative 10, right? Okay, so that means now I'm ready to graph. And let's see, I've got a vertex at 3, 8, then it's going to open down. Okay, so we got this. And then I have x-intercepts at 1 and 5. All right, so I'm going to draw it kind of like this. And we're going to see if I left enough room there. Okay, so I've got a vertex at 3. And I need 8. 1, 2, 3, 4, 5, 6, 7, 8. 3, 8. Okay, I have x-intercepts at x equals 1. All right, and then I have 1 at 5. 1, 2, 3, 4, 5. Okay. And then I have a y-intercept at negative 10. We're not going to quite get there to hit that y-intercept of negative 10. That's okay that we don't make it. We only need 3 points to draw that parabola. Okay? And sure enough, it opened down. Are we good? If you had put that in your handy dandy calculator, if we had gone over here to Desmos, do I see it? There it is. And I put that in. If I put in negative 2 parentheses x minus 3 squared, then plus 8, you would notice here is, you can actually just touch it and it'll tell you that vertex is 3, 8. You can touch those x-intercepts right there. It'll tell you that it's 1, 5. And then if you come down here, it will tell you that that y-intercept is 0, negative 10. Okay? But that's why we don't really let you use a calculator here. We would like you to do math. Okay, so that's example 1. Let's look at example 2. I'm going to flip to a new page. It's a little lengthy, just when we graph it. So we want to graph f of x equals x plus 3 squared plus 1. Okay, once again, I'm going to match it with my equation. I know this is in what? Standard form again, vertex form. So I'm just going to write that underneath there. That's ax minus h squared plus k. Okay, so step 1, it wants to know what a is and how it's going to open up or down. So is this graph going to open up or down? It opens up because a equals 1. When there's nothing there, it's assumed to be 1. Okay, there's assumed to be a 1 there. So A is 1. It is positive. It will open upward. Okay, step 2, we are looking for the vertex, correct? Okay, this one's friendly. I know that my vertex is going to be HK. I know I need to change that sign, so what's my vertex going to be? Only on the H.
-3 plus 1.
-3 with positive 1. Good. And now we're ready to find our x-intercepts. Guys, graphing is not hard if you have the process to do. Okay? If you know your steps, if you know your formulas, you're good to go, right? So I'm going to take my x-intercept. I'm going to find those. I'm going to take my function. I'm going to change. You guys have told me f of x is the same thing as y. So I know I have y equals x plus 3 squared plus 1. I'm going to make y turn into 0. I get x plus 3 squared plus 1. Okay. I am going to subtract 1 from both sides. And what do we notice here happens?
We're left with a negative.
We're left with a negative when I have to take the square root. So that means you're not going to get real solutions here. That means it's not actually ever going to hit the x-axis is what that means, okay? There's no real solutions, so it doesn't ever hit the x-axis. Now, it opens upward, so that means it's going to float somewhere above the x-axis, okay? I'm going to go ahead and I'm going to take the square root of both sides so that you can find the solutions there. So I know that the square root of -1 is really what? I. So I get plus or minus I equals x plus 3. I'm going to subtract 3 from both sides. And that's going to give me -3 plus or minus I equals x. Okay, so your two x-intercepts there, which they're not real, so we don't actually hit the x-axis. Your solutions are x equals -3 plus I and x equals -3 minus I. Okay, so if they had asked just for solutions, we would know that. No real solutions. Okay, so there's not actually an x-intercept, but we do get, we're going to go ahead and list that because that is part of our process. Okay. Step 4 is to find the y-intercepts. Okay, so I'm going to go over here to my y-intercepts. And I'm going to take my function y equals x plus 3 squared plus 1. And I'm going to make x 0. So I get y equals 0 plus 3 squared plus 1. So y equals 10. That one was pretty nice, right? Okay, so we get a y-intercept of 10. Now, we do have a slight problem here because what do we have? We only have 2 points. But I'm going to show you how we're going to fix that and we can graph. So I need to draw you've done all your steps. And if I have a vertex at -3, +1, right? Okay, there's my vertex. It's going to be my lowest point, because it opens upward, and then I have a y-intercept at 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Now, here's how we find our other point. We talked about the axis of symmetry, and that the axis of symmetry runs through the vertex, right? And what does the axis of symmetry do? it cuts that parabola in half. It goes, okay, if I fold it over the axis of symmetry, I match it up on the other side. Okay, it lands on itself if I fold it over the axis of symmetry. So what I need to do, all I have to do is I go, okay, well, how far away is that y-intercept from that axis of symmetry? Well, 1, 2, 3. That means when I fold that over, when I fold that parabola over that axis of symmetry, there will be another point exactly 3 units away from the axis of symmetry. So 1, 2, 3. Now you've got your 3 points. You can graph your line. Graph your parabola. It's not a line. Yeah, that's too long of a distance for me to try to. Y'all know I'm not great. There we go. Almost. Okay. So that's how you can find another point. If you've got your vertex and then you have a point on the right or the left, as long as you have a point on either side, 1 point on one side of the axis of symmetry, count over how far it is from the axis of symmetry. You're going to have a neighbor that many units on the other side of the axis of symmetry, because that's what an axis of symmetry does. You fold it, it matches. It's like a stamp. It was like when you were a little bitty, and then, yes, Edom?
Vertical is -3 and positive 1. But this is -1. Vertex.
The vertex?
Yeah.
You
Did I-
put vertex in long spot.
Oh. Y'all let me go and graph that whole thing? I sure did, because the vertex is what? -3, positive 1. Guys, why didn't you let me do that? Edom, you should have stopped me sooner. You probably tried. You probably raised your hand and I just kept on talking. Okay, yeah, that's why some of you are looking at me like real funny. Okay, that point's still there. This one's still there. Those two are still there. I just got to move my... Yeah, it says positive 1. I got it. I did it right. I graphed it wrong. See, this is why I need more sleep. There we go. Now, my apologies, guys. Hey, that's not too bad. I made it to Thursday. Well, y'all think I made it to Thursday without making a major... There we go. Now, is that better? Yep. Yes, that is better. Because our vertex is 3, -1. Guys, right here. I even wrote it, and I graphed -3, -1. Okay? Now, finding that extra point, that still works the same. All that was good. I just needed... Well, see, it was much easier to graph with it being 2 units up instead of down. Okay, that is example 2. So not too bad. Let's look at what happens when it's in general form. You know we got to do a couple of those, right? So there's example 2. We can erase part of this. His little tail here. And we'll go to example 3. Let's see if I got enough room. Yeah, I got enough room. Okay, example 3. Pretty much same directions. We're going to graph f of x equals -x squared minus 2x plus 1. Okay? This time we are in general form, which is f of x equals ax squared plus bx plus c. Now, because we have to do a little more work here, we need to go ahead, we're going to go ahead and list A, B, and C. So I've got A, B, C. What is A here?
-1.
Yep, -1. B is -2, and C is 1, correct? Okay, so step 1, same process. We go, okay, is it going to open upward? Is it going to open downward? We're looking at, it opens down because A is -1. Opens down, we'll say downward. A equals -1. All right, first step done. Step 2, I need a vertex. Okay, so we've got to remember the formula for the vertex given the general form. And I know that my vertex is going to equal -b over 2a and f of -b over 2a. Guys, that's a lot easier than it looks. All right, so what's -b? If I put in -2, right? That's what I'm doing. Over 2 times -1. Okay, before I fill in that other part, I'm going to make that look nice. A -2 is +2, right? Over -2. So that x value of my vertex is -1. Do we agree? Did I do it right? Is -1, correct? If I do a -2, that's +2 over -2, which is -1. So we're saying the x value is -1. Guys, we're saying -b over 2a, this chunk, really equals -1. So all I'm going to do is go up here and say, okay, I want f of -1. That's what I'm looking for. How do you find f of -1? Plug it in, right? So I know that f of -1 is going to equal -1 squared minus 2 times -1 plus 1. That gives me a -1 plus 2 plus 1, and that's going to give me 2. So f of -1 actually equals 2. So we get a vertex of -1, 2. All you do is find out what -b over 2a is. That's the x value. I need the y value with it. Plug it in. Get y. Okay? That's all it's saying. Do you have a game Tuesday?
I have one Tuesday.
Okay, you know we have tests Tuesday. Are you going to be gone in the morning?
I don't know what time it is. I'll check.
Okay. The only reason I know is because the boys have a game that day too. And Popovic, I can't say his first name. He's from Austria. I don't know his first name. He's like, we got a game, but it's late. I might be here. But he has an afternoon class. So, but I didn't know what time I just figured y'all had a game. But I didn't know. And we'll need to, if so, we'll reschedule we'll have to make a time for you to come in and take your test, okay? You can make it up because you got a game. Hold on, Jaylene came over. Okay, vertex, good. What's 3? X-intercept. All right. So we're going to, and of course I don't have enough room. Let me do 4 down here for my y-intercept. We're going to say x-intercept, y-intercept. We know that's what we're finding. And so then I can find my x-intercepts right here. So I'm going to take my function. Y equals -x squared minus 2x plus 1. And I'm going to make, 0? Y 0, right? Oh, and y'all are like, this is not friendly at all. Well, the first thing I'm going to do is I'm going to make that -x squared positive. Let's see what happens there. Okay. And I think it's going to wind up not being friendly. if I were to add these over, and I got a positive x squared plus 2x plus 1 minus 1. Okay? I added, changed the sign. I know it really didn't, I didn't have to do that because 0 doesn't really change the sign. But we're trying to make that a positive. Okay? There's nothing that's going to multiply to be negative 1 and add to be a positive 2. Okay? So we're looking at, let's use quadratic formula and find those x-intercepts. Okay? So I've got negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay? So that's going to give me a negative 2 plus or minus the square root of 4 minus 4 times 1 times negative 1 all over 2 times 1. That's going to give me negative 2 plus or minus the square root of, well, 4 and then plus 4, right, is going to give me 8 over 2. And that's going to give me negative 2 plus or minus 2 square roots of 2, because 8 is really 4 times 2, all over 2, which is going to be 2 can go into the 3 outside 2's, negative 1 plus or minus the square root of 2. Okay, so it's not a friendly number. It's not completely unfriendly. We have some x-intercepts. But, of course, I know square root of 2 is 1.414. Okay, and so if I'm saying negative 1 plus 1.414, that's an x-intercept around 0.4. And then if I subtract it, there's going to be an x-intercept around a negative 2.4. Okay? Now, you do have your little handy-dandy calculator that you can use to put that in. So if I used, let me use the appropriate calculator, not Desmos. Where is it? Where I had it the other day. Up there. Okay, so if I actually put in, what was it, square root 2?
Square root 2.
Okay, and then I want to say, was it plus 1?
Minus 1.
Okay, yeah, so plus, yeah, because it was plus a negative 1, right? And so I get a 0.414 approximately. Okay, so I know one of my x-intercepts is 0.414. We're going to say approximately. And then the other one, I've got a minus and a minus. Oh, look what I learned to do. And I knew I could do it, but I had forgotten I can do it. Ta-da! So then you can see, and I can see. I've got a negative square root 2
Are you on the calculator?
minus 1. Yeah.
Oh, we can't.
We can't do
It
it.
didn't pop. Do you know it popped in the other class? Like in this building. The other class, it popped. Like they could see my calculator sitting right beside my... That is weird. Okay. All right. So negative 2.4, that's so weird that it didn't show you that. Approximately a negative 2.414. Okay? Those are your x-intercepts. All right. Let's try to find a y-intercept. Okay? So y-intercepts, I've got y equals negative x squared minus 2x plus 1. I'm making x 0. That's real friendly. So that's going to be a 0. That negative 0 squared didn't do anything to me. 0 plus 1. So I've got a y-intercept of 1 is my y-intercept. Okay? Now, I'm going to have to flip a page to graph it. Okay, so let me go over here. So So we have, and I don't know if that's gonna be big enough. Where am I at? We know it opens downward. Hold on, I'm gonna copy this. I'm gonna lasso it. And we're gonna go over here. Since I greatly misjudged. Okay, so we've got a vertex at -1, 2. So let's see if I can actually plot a point right this time. -1, 2, okay? I've got a y-intercept at y equals 1, don't I? I went to 2. Oh my gosh, guys. There we go. At least I caught it this time. -1, 2. And then I've got, those x-intercepts are weird. I don't really want you guys graphing because we can't accurately get those real good, right? But I know I have a y-intercept at y equals 1, so I have this point right here. And if I go with my whole, all right, here's my vertex, here's my axis of symmetry, and I check out how far away is that y equals 1, that y-intercept from the axis of symmetry. It's 1 unit away, right? So I can make another point 1 unit away. And then I don't have to worry about those x-intercepts, okay? So I can simply just go, and honestly, when you draw them, those x-intercepts do kind of show up in between there. We got an x-intercept at approximately -2.5 and 1 at 0.5, even with my poor drawing skills, okay? And I'm showing we only have one more example left. Surely there were more than this back then. I think I was tired by this time. Evidently, I taught this class summer. This one, these notes came from summer of 2020. And this was the first class they reopened back face-to-face after we'd gone home. Were you in the service in 2020 when COVID hit?
2020, I was in South Carolina.
Okay, so, yeah.
I was in training.
Well, I'm sure that was real pleasant.
Well, it wasn't basic training.
Oh, it was a different kind,
Yeah.
yes. Still, that wouldn't have been a fun time to have been in the
No, I was
military.
stuck on a base, wasn't allowed to go. We had
Oh, yeah, they
to
like
kick out the
quarantine.
soldiers.
Yeah, they quarantined and sent y'all all away and all kinds of stuff.
No
Yeah.
one was forced to get the vaccine or get kicked out. You were forced to stay on base. or
And
get
then,
kicked
of
out.
course, if you said you wouldn't take it and then you got kicked out, then you don't get any benefits whatsoever because it's it's not one of those nice discharges.
No, it's
Um,
administrative/medical.
But
Um,
no benefits coming
yeah.
back. Yeah.
You can eventually get benefits if you petition for it, but it takes up to a year to process through.
And how much money do you have to get a lawyer to do that? Like-
You can. It depends on the case.
But still,
for
it's going to
that-
wind up costing you money, and you got to fight for a long time. Yeah, so y'all lined up and you took your shot and went on. Yeah, and hope you didn't die. Consider the quadratic function f of x equals -3x squared plus 6x minus 13. Yeah, this was the class where they were like, okay, we can't put 20 people in there. We can put 10 people in there. Everybody has to wear a mask, and you have to teach with a mask. And everybody has to, like, there was one person per row, but then you couldn't be, like, you had to be as far as you three apart because it was supposed to be 6 feet. And then so you wouldn't have been able to sit there. You'd have had to come back up here. And then I had to manage all that and go, oh, no, you got to move around. All I'm wearing a mask like this. And I'm, breathing in my own germs and carbon dioxide going, this is not really safe, but we'll do this. And then you had kids going, oh, I got COVID. I can't come to class, but you got to excuse me, even though they didn't have to have, there was no way to track medically, like, by the time all that got processed over there, it was like the class was going to be over because, it was like only 5 weeks long. It was, yeah. Consider the quadratic function f of x equals negative 3x squared plus 6x minus 13. A says determine if the function has a maximum or minimum. Okay? Okay, well, is he going to have a maximum or is he going to have a minimum? So, what is A? We can tell that from whatever A is. What is A? Negative 3. So, this means it opens what?
Down.
Opens downward. And guys, if it's opening downward like this, is this vertex a max or is he a min? He's a max because he's up at the top of the hill, okay? So that's a maximum. Well, that was a pretty friendly question, okay? B says find the minimum or maximum. Because they didn't want to give it away, the answer away. Find the minimum or maximum and determine where it occurs. Okay? Okay, remember where it occurs is the which value. That was our whole Mount Everest in Nepal. Where does it occur? Which value is where it occurs?
The x value.
The x value. So make yourself a little note. X value is where it occurs. And the y value is what it is. It's the actual value. Like if you had it, it's a maximum, we know that. And it would have a max of maybe 10, and it occurs at 2 because the vertex is 210, okay? So we need to find the vertex. All right, so we are in, which kind of form are we in? We're in general form. So I know that my vertex can be found with negative b over 2a, and then f of negative b over 2a. Remember, that's just the corresponding y value. I'm going to show you. Okay? So, if I have negative b over 2a, that's going to equal 6 over 2 times negative 3, which gives me 6 over negative 6, which is negative 1. Everybody okay with that? Did I mess up? What happened?
So with the negative b, it would be negative 6,
Mm-hmm.
not 6.
Oh. I think I even know I did it right over there. Yes. Me and the negatives aren't getting along today. That's sad. That means I should go home. And today's the day I have to teach until 8:40 at night. That tells you how that class is going to go. That 6 to 8:40 class is not going to go well tonight. Maybe I should nap sometime between now and then. That is a negative 6 because it's negative b over 2a. So I've got a negative 6 over 2 times the negative 3, which does give me a negative 6 over negative 6, which is positive 1. So I know this is a positive 1. Now I got to find the y value that goes with that. So I want to find f of 1, and that's going to be negative 3 times 1 squared plus 6 times 1 minus 13. Make sure I wrote it right. That's going to give me negative 3 plus 6 minus 13. And that's going to give me what, a negative 16? No. Nope. That's going to give me 3 minus 13, which is negative 10. Going to give me a negative 10. That's positive 3 minus 13 is negative 10. So I get 1, negative 10. And I was just guessing on the 10 over there a while ago. Okay, so that's my vertex. So let's write it. The maximum is negative 10, and that sounds weird, doesn't it? At, and occurs at x equals 1. That sounds weird, doesn't it? But that's right. Okay? It just means, what does it mean? We're at x is 1 and y is negative 10. It does open downward, we said, right? So it's going to be in that fourth quadrant. Guys, just the small sketch. It should be like this way down here. Something like that. Okay? Because positive 1, negative 10, I do have x is 1, right? Yeah. Because that was my whole 6 debacle. My negative 6 problem over there. Okay, C asks me to find the domain and range of the function. Now, the domain's easy. And actually, once you've determined if it's a max or min and found that vertex, the range is too. Okay? So on my domain, and we don't actually have to graph it this time. C's the last part. On my domain, remember, domain is the one where I look at that function and I go, okay, do I have an x in the denominator? Do I have an x in a radical, like a square root, an even root? Okay, do I have x in a denominator? Nope. Do I have x in a square root in a radical? Nope. So I can just go, all right, my domain's negative infinity to infinity. What that means is I can pick any x value, plug it in there, plug it in that function, any x I want, and I'm going to get a y back. I'll get an answer back. I get a friend. He gets a y friend back. Okay? That's what that means. Now, our range, okay, that's where we talk about a bottom to a top. Well, you've told me it has a maximum point. Okay, well, if it has a maximum, that means do I start there and go up, or do I come from the bottom and hit that? If it's a maximum, and like I said, it looks something like this. Okay? It was in this right here. Somewhere like that. Okay? So, am I starting at the point and going to infinity, or do I start at negative infinity and come up to the point in that picture?
Negative infinity to the point.
Yes, negative infinity and up to the point. So, because if there was a little bug and he got on down here, wherever, he's way down here, his y's, he's in negative infinity. And he's going up, and he gets up to where? Where was the top of Mount Everest for him? Who was that? Well, not where. What is the top of Mount Everest? Negative 10. And then we actually put a bracket on negative 10 because he gets to sit. He makes it to the summit and is not dead yet. He makes it up there, and it's like, now it's time to come back down. Okay? There he goes. And it's at negative 10. He comes back down. Now he's going back to, and you've done your domain and range. Okay. Now, my notes 5 says, write an equation in vertex form. Notice they're calling it vertex form here. Of the parabola that has the same shape as the graph of f of x equals 8x squared or g of x equals negative 8x squared, but with the given maximum or minimum. Okay. And it says maximum equals 7 at x equals negative 8. Okay, so it actually gives us quite a bit of information about that. Write an equation in vertex form of the parabola that has the same shape as the graph of f of x equals 8x squared or g of x equals negative 8x squared, but with the given maximum or minimum. Okay, so pretty much they're telling you A, right? They're saying A is going to be, and they're trying to tell you if it opens upward or downward depending on what they say down here, with the maximum at 7 and x equals negative 8, maximum of 7. Okay, so let's talk about vertex form. Vertex form was the standard form that we wrote, remember? And it's going to look like f of x equals a x minus h squared plus k. Sorry, laptop's going to sleep. Okay, f of x equals a x minus h squared plus k. Now this tells me it has a maximum. So if it has a maximum, does it open up or down? Down, because if I'm a maximum, I'm at the top of the hills, right? I'm at the top of Mount Everest. I'm not in a valley if this is a max. So it's saying my max is at negative 8, 7, correct? Okay, it's at negative 8, it is 7. So that means, okay, so we've got opens down, and we have a vertex at negative 8, 7. Because it told me maximum equals 7. All right. Well, once I know it's a maximum and I know it opens downward, I can decide if I need to use f of x or g of x. Which one do I need to use?
G of x.
G of x, because a is negative, okay? I need to use g of x because it opens downward. So I'm going to take g of x equals negative 8x squared, and I need to write it with a vertex of negative 8, 7. Okay? Well, guys, all they gave you there was a. It's fine. Okay? So we've got a negative 8 x minus h squared plus k. All right? Because this is your a. He just moves on down. And we want to write it in vertex form. So I take my vertex now, and I've got negative 8 x minus negative 8 squared plus 7. Clean it. Negative 8 x plus 8 squared plus 7, which I've had quite a bit of trouble cleaning, haven't I, today? I've not done a good job. Okay, so we're saying we've written our equation. Let's see if they like it. Or maybe I've just lied to you again over here. If I can type correctly. I'm going to be honest with you, I'm not a fan of I have a love-hate relationship with a math software program. Hate typing in there. But I love that it does grade your homework for me. That's all. Was somebody coming in?
Somebody walked in and walked out.
Oh, was it it is getting time for the history class that comes in. They probably thought they could come. It wasn't somebody that usually comes in here, right? It's next class, okay. Oh, we got it right, by the way. Good job. 2, write the following parabola in vertex form. The vertex is at -5, -3, and the graph passes through the point -1, 1. Okay, we might ought to do that one. We got 6 minutes. What example is this? 6? Okay, write the equation. In vertex form. And I have vertex is at -5, 3. And the graph passes through the point -1, 1. Okay? Now, at first glance, you're like, we don't need that point -1, 1. We got a vertex. We got vertex form. F of x equals a, x minus h squared plus k. Guys, here's the problem. When you go to plug that in, you don't know what a is, do you? You've got a, we can plug in the -5, 3, so that's x minus -5 squared plus 3. So I've got f of x equals a, x plus 5 squared plus 3. But I still need a. Well, that's where this point -1, 1 comes in, okay? Because here was my h, here was my k, this is an x, and this is a y, right? There ain't no a there. Well, what's this really saying? This says y equals a, x minus, or x plus 5 squared plus 3. So I've got to find a. All right, well, do I have a y I can plug in there? Yeah. Do I have a corresponding x with that y? Yeah. Of course, I've already put my hk, so if I can fill in a y and I can fill in an x, I can turn everything into numbers except the a, then I can solve for a. Okay? So I'm going to say 1 equals a, -1 plus 5 squared plus 3. That's going to give me 1 equals a. Then I've got 4 squared plus 3. So I've got 1 equals 16a plus 3. Now you can solve for a, right? I'll subtract 3 from both sides. That gives me -2 equals 16a. Divide by 16. And that gives me -1/8 equals a. Something happened. What happened? Did I plug it in wrong? Okay, we'll go passes through -1, 1, negative, Now, this would be fine if I had written the vertex correctly. The vertex was actually -5, -3. This is how you work the problem, though. You got the right answer that's A. So now write your equation. F of x equals -1/8. There's something about the negatives today that's just not jihad, is it?
Are you saying that the 5 is -5?
No, the 5 was a -5. It's fine because it's x minus h. So minus the negative gives me a plus 5. But in the problem on the homework, it was -5, -3, not +3. And we worked the whole problem with it being 3. So this would be your solution to this problem. You worked the problem I gave you correctly. It's just not the problem that's here. But it's the same gist. You know, they changed the numbers on y'all anyway. So we would get -1/8 times x plus 5 squared plus 3. Okay? Because if I change that, that would be a -3. Yeah, we got that. And then that would be a +5. Oh, well, I can just pick that. I don't even have to find A. They make that easy on y'all. Yeah, we're good. Okay, so I will check over the rest of the problems, and if I need to add some extra ones on there, like examples on there, I will and post it. But I think you can work the rest of your homework problems. I think you're good to go, okay, for the 3-1. All right, guys, and I did set the 3-1. It's not due until the end of Unit 3. Y'all have suffered enough through Unit 1 and Unit 2 by the week having to get your homework assignments done. You guys are still here with me. You know how to study, okay? You know how to keep up. So all Unit 3 is due like November 6th, like every homework assignment for Unit 3. So chapter, whatever we're doing here, is November the 6th.